This is my micro teaching 2 about electric lanes. The standard that we're going to be covering today is S6E6, Section A, which is ask students to determine the differences between renewable, sustainable energy resources and non-renewable energy resources and how they are used in our everyday lives. The introduction question that I hope some of you guys can answer is, how many sources of energy can you name?
Fuel,
Fuel, okay.
I guess.
Electricity.
Solar.
hmm But sources of energy, so where does fuel come from? Does anybody know where fuel comes from? Or
The ground.
well, that's sort of what we'll be that's sort of what we'll be covering today, where that gas comes from and where that electricity comes from. And some of the energy resources that we use today is it varies from non-renewable to renewable energy, which are things like hydro energy, petroleum, coal, natural gas. There's just different types. It just depends on the state you live in. Some are more environmentally friendly than others. And all these different types of sources of energy are categorized into two types of energy, which is non-renewable and renewable energy. And for non-renewable energy, it's sort of hinted in the name that it's energy that comes from a natural source that cannot be rapidly replaced or is irreplaceable. The most popular one, something that's been around for a very long time, is fossil fuels. The word fossil fuels is actually comes from a group of energy resources that are formed from prehistoric plants and animals, among other things. So what happens is that when animals and plants die, over time they get layered by rocks. And as soon as they get layered and layered and layered, heat and pressure begins to build up, which then turns the fossil into coal, oil, or a natural gas. As I mentioned earlier, these coal, natural gas, and petroleum, they're all members of fossil fuels. And we're very dependent on fossil fuels. We use them to run cars, computers, and just about everything we use today. And the United States and Russia and China are the most largest coal deposits. So we bring in a majority of fossil fuels. And the majority of it comes from the Middle East. So that's why there is a lot of dispute sometimes in the Middle East, because it's always about their fossil fuels they have. Some advantages and disadvantages of fossil fuels is that they are cheap, reliable, and they are well developed. We spend so much time with them that we just find more ways, faster ways to get it out of the many layers of rock. We have spent so much in technology of finding the actual fossil fuels. So we're just like really well invested in it. And like I said earlier, almost everything that we own is powered by some sort of fossil fuels. Like, what's one thing that gasoline runs in your household?
And Hi everyone, good afternoon. This is Valina Spencer, and today my micro teaching number 2 is on learning gizmos. We affectionately call these gizmos for our students, and this is a cutting edge technology that is on the internet that I'm going to show you guys how to use it, and hopefully you'll be able to use it in your classroom. Like I've just learned how to use it from one of my fellow teachers, and I think it's been pretty fantastic. So there's a lot of different features for it, and I'm going to go through it now and show you how to utilize those features. The Gizmo has a website that is explorelearning.com, and so if you go to another website, it won't be there, but this is explorelearning.com. You'll be able to go there and see the system that is definitely a cutting edge technology for science. They also attribute it to mathematics as well, and each of the gizmos is aligned to all of the Georgia standards. So you'll be able to search, and I'm going to show you later how to search for your standards and utilize it. This is what the web page looks like when you come to it, and in the county that I work in, we are automatically signed up for it. So that's a good thing, and the online simulations power inquiry and understanding. They're very, very cool little observations that I'm going to show you. And the gizmos are here to help in the event of a school closure. You can utilize these for all of our online platforms. It will enhance the learning of all of the students and give them more depth of knowledge and other activities. Some of the highlights and features of the gizmo is that you sign up through your district, and they give us access to it, and there's also a free login for others as well, so we can maneuver it and utilize it. We access it through another system that's called ClassLink, and the students can go there first, and then they're able to go and access the gizmos on one of their apps. So it integrates with IsLearning. IsLearning is a platform where we put our lesson plans, where we can also put our assignments, and we can collect assignments. So when I was shown about this particular gizmo with the assignments, you can assign it to your classes. And so based on where your classes are, you can add it to the class, you can add an assignment, and it's already connected with IsLearning. So the classes have access to it, which you wanted to try to make it as easy for students as possible. There's so much technology that's happening now, right, that the students are really just having a hard time getting places. So you can spend a lot of time teaching technology, but that's why I like this one, because it makes the technology fun. So one of the big points is that you search by standards. And I'm going to demonstrate most of this to you today, but searching by the standards is what we're required to do so that you align each lesson to the standards. You can also search by your grade, by your topic, and by some textbooks are also added. You can use Quick Launch to start your gizmo, and there are other features here that are different things that keep the kids, the students, active in their learning. There are exploration sheets, activities. In science, you can utilize the experiments that come along with it. They give detailed information on that. Questions can be answered and asked. You can also do other simulations with right on screen. So because you're not face-to-face in your teaching, then the simulations really work well to get the kids active. And so some of the simulations are like little video games, which everybody likes video games most nowadays. You need them to be able to do something because they're behind the screen and it's like low touch and no feel. So to pull them in and to draw them in to work the gizmos, I'm going to show you one. So there are also videos, and another one that helps with our literacy is the vocabulary words that will go along with each lesson. Gizmos is where science and technology meet in the virtual classroom. Now I'm going to go to the web page and show you the gizmo. So first we want to go to Explore Learning. .com. And we're going to wait for the website to come up. We're going to hope that it comes up. And we are having a failed attempt to go into the gizmos at this time. Let's see. Here we go. Okay, we're going to continue to the home page at this time. I wanted to, and so here is a setup. It's a nice setup of the classes that you can see: Earth Science, 2nd period, 3rd period, 4th period, 5th period. And this is where we started. So here are the academic standards here. The Georgia standards are pulled up. You can browse and see that all of the standards are here for math and all the standards are here for science. You can choose which standards you're going to work with. Let's go to 6th grade. So our 6th grade S6E Earth Space Science is here. And this is the lesson that we were going to focus on is S6E1C. Analyze and interpret data to compare and contrast the planets in our solar system in the terms of size relative to Earth, surface, and atmospheric features, relative distance from the sun, and ability to support life. So this would be the start of one of the gizmos. So you can see it explains, you have lesson info here. You can launch the gizmo, or you can add this to your class. So again, your class can access it through the ClassLink platform. I'm just going to launch this gizmo. Fantastic. Now, this gizmo here is going to show us the solar system. And we can read all about it. One of the literacy techniques that you can utilize is to let the students read each of these. So if we go to the full screen mode, you can see that there's information on the sun. Drop down box will show you all of the other planets as well. So you can pick your favorite. So can somebody tell me what's your favorite planet?
Saturn.
Earth.
Saturn and Earth. All right, let's go for first. Let's go for Earth, of where we are in this gizmo, right? So Earth is here, and we can read all about Earth. Earth is amazingly well suited for life. Its atmosphere warms the surface at night and burns up meteors. Earth's magnetic field shields us from harmful radiation. Earth is called a water planet due to the volume of water on its surface. And the Earth moon is so large that some scientists consider the Earth and the moon as a double planet. So here on our gizmo is Earth. So once you hover over any of the objects, you can see what they are. We have the sun, Mercury, Venus, and Earth. Now, you can also see where the Earth is going to be in the solar system, maybe on your birthday, maybe on a holiday. And once you click play on the gizmo, they can start to rotate around the sun. And this is actually called an orbit around the sun. So then we can show our orbits. So you can see how long it takes and what month we're in and where we'll be we're already in 2021, we're moving 2022. It's like going forward fast in time, right? This is a fun one, right? You can make it go faster. Ooh, that'll make you dizzy. All right, let's slow back down. Okay, so we have the Earth. Now let's zoom so we can see our other planets. We're gonna zoom out and we get to see Jupiter, how far away it is. We zoom out again. There's Saturn. So then we go over to this gizmo, and again, people are learning by clicking and being interactive. And we have Saturn, which is the other student's favorite planet, and it's a huge ball of hydrogen. So this will show you the relative sizes of the Earth and the different planets. So Saturn is so light compared to its size that it would float on water. So Saturn is huge. Saturn's rings have dazzled astronomers for centuries. Recent varied spokes were found on the rings. Scientists do not understand how these rings themselves were formed. So this is how we can see the planets move. Now you'll notice a couple of things on this gizmo. And then there's another tab up here that shows the relative size of each planet. And you can click on there as well and learn about the relative size of the planets. So that's really cool. Now on the bottom, I want to show you some of the other items that you can utilize with this. And one of them that I utilize the most would be, I use the gizmo. We have these gizmo documents, which give you a little bit of assessment. So here you see they provide to you the student exploration of the solar system. And this is for prior knowledge. So the students can use this for prior knowledge, and we can make a list of all of the planets you think of and continue to go down and learn these different planets. So this gives a teacher what they really need, right, to succeed in so many ways. And then this one is utilized after the gizmo is used. So those are some of the different technology-based learning that Gizmo provides for us. And I just want to thank you guys, and hopefully you enjoyed learning about that today. Have any questions for me? Or you can tell me what your favorite part of that gizmo was.
I think it really brings into perspective how small Earth is. Like when you keep zooming out, I mean far away, that's what I meant. It really shows how far away other planets are from the inner planets.
Yes, it does. That's the purpose of it. Well, thank you so much, y'all. Have a wonderful day.
So, hello, everyone. Today we'll be talking about a new cutting edge piece of technology that's been around as early as 2013, but I'm just now finding out about it. And it's known as the CubeSat, short for Cube Satellite. All right. So this cutting edge piece of technology is aligned to standard S6E1 A through E. Those standards encapsulate weather, space, planet, Earth surfaces, and a little bit more. All right. So before we get into today's lesson, I would like to ask you all two brief questions. What are some functions of satellite, and does the size of a satellite matter?
There are satellites to take pictures of space.
I was going to say the same. It's sort of to find the location, like Google Maps and stuff like that, to sort of find the location of specific things.
Okay.
GPS.
All right. Thank you all for answering. So these are all essentially basic functions of a satellite. And so what about the second question? Do we feel as though the size of a satellite actually matters to how effective it can do its job, or just period?
I would think that the bigger it is, the more ground it covers.
Yeah, I think bigger it is if like you can put more stuff to do more things.
Any thoughts, Francisco?
I was thinking, yeah, because like if it's too small, maybe it'll get like lost or something, and you're not gonna know where it's at because you need to know where your satellites are.
Okay, that is a good point. All right. So thank you all for sharing. All right. So essentially what we have here, so these CubeSats, they're very small spacecrafts. Being the fact that they're so small, they're able to be used for a variety of purposes, including some very high risk missions that essentially their low cost accounts for the potential of us losing the specific satellite. So what I'm trying to say is they're easily replaceable, so we can do more with them. So far, since about 2014, 1,100 CubeSats have been successfully launched, and over 80 have been destroyed in the process. So if you'll take a look over here, it's a very small thing, but it almost looks like a Rubik's Cube, but it actually packs a very big punch. I was watching a TED Talk on it earlier, and pretty much the speaker was saying that they put a lot of the latest technologies into this small cube. So it comes with a system designed for navigating, designed for taking pictures, tracking, pretty much whatever they needed to do, they can put it into that little box. All right. So I just spoke a little bit on what they're made of or how they're made. Let's talk about what Cube satellites actually do. So, like I said earlier, they're involved in a lot of high-risk missions because they're easily replaceable. But some practical purposes they serve are Earth observer, so we can put it up. We can put it up there to take pictures of essentially anywhere in the world, but just with more discretion. It can be used as an amateur radio. I'm sorry. All right. So they're typically employed to demonstrate spacecraft technologies, which are intended for small satellites. So they're not really going to have the variety of abilities that a larger satellite would, which I believe somebody said earlier. And they're also used for experiments that present questionable feasibility, so they're unlikely to justify large satellite costs. So what I meant by that is earlier I mentioned the high risk missions, but essentially what I surmised from my research was that scientists are actually they get pretty creative with these cube satellites. So they try to think of bigger and new. Essentially, they try to cross newer frontiers with these satellites, being the fact that they're so replaceable. So, and to justify the large satellite cost, pretty much what I meant by that is that they would never do the type of missions or trials or experiments that they do with these small satellites with a larger satellite. All right, so here I just have a comparison of both. My larger satellite got cut off a bit, but I'm sure you all can imagine the rest. So really, they may look a bit zoom. I mean, it's zoomed in, so the cube satellite actually looks pretty big, but they're actually not that big. They're actually not that big. They actually range from the size of a Rubik's cube to the size of a loaf of bread. All right. So and really, this picture was just here to compare the cube satellite to an actual conventional satellite. So the conventional satellite may have a wider array of uses, but what I believe the cube satellite offers, which can be so valuable, is depth. So and they're easily replaceable and manufactured. So it's kind of like a conundrum if you would have to pick between 10 cube satellites that can do 10 different things, which would be cheaper to manufacture, easily replaceable, or one satellite which can do the same 10 things, but it takes longer to make. There are more logistics involved into it, probably harder to get into space. So these are just some pros and cons between our cube satellite and our conventional satellite. The cube actually in this visual, I selected this visual because it almost looks like a toaster to me. I don't know if anybody has seen Jimmy Neutron growing up. There was an episode where he actually made a satellite out of his toaster, and I just found that to be pretty entertaining. All right, so on this slide, I just wanted to review some of the benefits of CubeSat satellites, essentially reviewing what we've talked about so far. So cube satellites they're cheaper. So like I said earlier, they're easy to manufacture, they're easily replaceable. They're limited in their abilities, but they do them very well. So that goes back to what I mentioned earlier with the comparison of 10 cube satellites and one conventional satellite. They're very versatile in their uses, so we can make 10 different cube satellites do 10 different things. Some of those capabilities that have been programmed or experimented with the cube satellites have been weather prediction. They can help with climate change. We all know there's a big population of the American population who believes climate change is a hoax. Well, something like the cube satellite can help propose more concrete evidence to the disbelievers. So it can track urban growth. We all know the Earth is expanding at a very rapid rate. I believe we're about 7 billion now. So it can do stuff like that. Water, it can track water patterns all over the world, anywhere in the world. Crop yield, this is something that also happens. This is also something that can happen very on the macro scale, essentially. All right, so before we go, our exit ticket is, I want you all to really, let's take about 15 seconds, and I want you all to really think, and I want an insightful answer. If you had the power, or not power, if you had the access to daily images of anywhere on the earth, anywhere, anytime, what would you do with it, and what problems would you solve? All right, so let's take 15 seconds just to get the brain juices flowing.
I
Go ahead.
So because it's COVID, right? When the pandemic, you could track crowds of people gathering.
Ooh, very creative answer, Valina.
Thank you. You could see where it was too many people at, and then, well, we'd have to find a nice way to disperse people because I don't want to incite any violence at all. I want it to be peaceful, but that would be a good thing to notice.
Okay, thank you for sharing.
One thing that I'm thinking about is because ice is melting a lot in the North Poles, I think it would be nice to see how the ice caps get smaller.
Okay,
Mm-hmm.
good answer, Steve.
Yeah, I'd like to see the trends of people moving into and out of cities, you know, and see where all the people like living at.
Okay. All right, good answer, everybody. Very, very thought provoking. All right, well, that's about it for me for today. Um, Thank you.
I have a question.
Oh, sure.
Yes, so I was thinking that satellite was really kind of small. You said it was like a Rubik's Cube. Is this small?
Yeah, it can range from a Rubik's Cube to a loaf of bread.
Okay. And what would you want to track with what would you want to track?
Right.
Yeah.
I would want to use it to solve crime if that were possible.
How?
You said how?
Yeah, how?
Like maybe let's say just an extra eye in the sky, keeping an eye on bad guys, if you will, for lack of a better term, and just stuff like that.
Okay. All right.
So my presentation is about renewable and non-renewable energy. The standard it's going to be covering is S6E6, obtain, evaluate, and communicate information about the uses and conservation of various natural resources and how they impact the earth. And then it was A, ask questions to determine the differences between renewable, sustainable energy resources and non-renewable energy resources and how they are used in our everyday lives. So the learning objective is that students will be able to recognize renewable and non-renewable energy sources. So this cutting edge piece of tech that I saw, it was like a Game Boy lookalike, okay? But the thing is that it didn't have any batteries inside of it, and it was running on solar power and the button pressing, okay? So like it says right here, each button contained a small magnet that when pressed down or released, it moved through a wire coil underneath the button, and that change in the magnetic field around the coil generates an electric current that could be used to power the device. So it was powered, you were powering it by playing it. That's how it was getting its energy. Okay, so got any question? What is a renewable resource?
Is it to renew? Wouldn't it be something that can be repeated or be used again?
Yes, sir. Good answer. Valina, Dami?
Yeah. Like if you use it up, it's not actually used up. Like something that you can't actually use up. Like you really can't use up trees, I guess.
And yeah, I would say something along the same lines, something that we can always count on being there tomorrow.
Sir. So renewable resources are resources that can be replenished within a short amount of time, and they are remade naturally at the same rate that humans use them. So as we're consuming them, there's new ones being replenished and taking the place of the resources that we've already used up. So I have this video. Let's see. Can y'all see the video or no?
Not yet.
Yeah. All right. Let me change this.
Make sure you should share the sound. We can't hear.
So now you can see the video.
Yes.
All right.
You want to give us the sound?
It's an ad right now.
Okay.
Let me see.
Share the sound. You have to share the sound from your computer. Go to the top of the screen. Put your cursor all the way up to the top, and then it'll pop up, and it'll be like a little square next to a square.
Okay. Include. Why is it not doing this?
It's a little tricky. So you can unshare and reshare, and on that box there's a includes sound. It's on the top left. Yeah.
Okay, can you hear now?
Around the world, renewable energy use is on the rise. And these alternative energy sources could hold the key to combating climate change. What is renewable energy? Renewable energy is generated from sources that naturally replenish themselves and never run out. The most common sources are solar, wind, hydro, geothermal, and biomass. Over 80% of the total energy consumed by humans is derived from fossil fuels. However, renewables are the fastest growing source of energy in the world. Renewable energy has many benefits. First, it can combat climate change because it creates no direct greenhouse gas emissions. The only emissions that they produce are indirect, meaning those that result from manufacturing parts, installation, operation, and maintenance. But even those are minimal. Second, renewable energy can decrease pollution and therefore reduce threats to our health. Wind, solar, and hydroelectric systems create no air pollution emissions, and geothermal and biomass energy systems emissions are much lower than non-renewable energy sources. Third, renewable energy is a reliable source of power. Because renewable energy sources are, well, renewable, they will never run out. Once built, renewable facilities cost very little to operate, and the fuel is often free. As a result, renewable energy prices tend to be stable over time. While renewable energy has many advantages, it is not without downsides. It is difficult for renewable energy sources to generate power on the same large scale as fossil fuels. Building wind farms and dams can disrupt wildlife and migration patterns and lead to ecological destruction. Both solar and wind energy are intermittent. They only generate power while the sun is shining or while the wind is blowing. Batteries can store excess energy for later use. However, they are often costly. While renewable energy presents some challenges, it also offers an environmentally friendly alternative to the greenhouse gas emissions and pollution of fossil fuels. And as advances in technology make renewable energy more accessible, affordable, and efficient, an end to climate change could be within our reach.
Oh yeah, so that was a little video about renewable resources from our friends over at National Geographic. Hope y'all enjoyed that. All right, so what are some renewable resources that we learned from in the video?
Hydro.
Solar.
Yes, and Valina?
Wind.
Yes, exactly. So some renewable energy sources are hydro, solar, wind, geothermal, and biomass. Okay, so then what are some non-renewable resources? I'm sorry, what are non-renewable resources? Yes. So we just went over what renewable resources are. So what are non-renewable?
Something that once it's gone, it doesn't come back.
If you use it, it's gone.
Mhm.
And yeah, it cannot be replaced.
Exactly. So non-renewable resources are resources that cannot be easily replenished. They are replenished, but it usually takes like hundreds of years. So they're not a reliable source. So once you run out, you're done with it. So I have another video about those.
Smile and learn.
Non-renewable energy. We obtain energy from two different sources: renewable energy sources and non-renewable energy sources. Today we're going to learn about non-renewable energy sources. Non-renewable energy refers to the limited energy sources on the planet that don't replenish naturally. Coal, oil, natural gas, or nuclear energy are examples of non-renewable energy sources. In nature, there are limited resources of this type of energy. That's why they may run out with use. These are some of the most well-known non-renewable energy sources. Oil is found under the Earth's surface. It's a liquid substance formed by a mixture of hydrocarbons. Oil has a strong smell and dark color. Oil is used to produce fuels like gasoline or gas oil, which we use to power the engines of vehicles. Coal is a rock that is extracted from open-pit underground mines. It's a black substance formed by the fossilization of the dead remains of plants. When coal is burned, it produces heat. Natural gas is extracted from deposits found under the ground. We use natural gas to heat houses. Uranium is a chemical element extracted from underground shafts and mines. We use uranium to produce nuclear energy, which in its turn will later transform into electric energy. Non-renewable energies have disadvantages for the environment. For example, exhaust gases emit contamination gases in the atmosphere, which are harmful for the planet. As for nuclear energy, it is necessary to handle radioactive residues properly. When there's an accident related to non-renewable energy resources and residues, environmental catastrophes of great magnitude may occur, which are crucial for the Earth and all living beings. To reach the world energy objectives and help take care of the environment, it's indispensable to reduce the use of non-renewable energy resources and accelerate the transition towards renewable energies.
All right, so that video is about the non-renewable resources. So what are some non-renewable resources that y'all saw in the video?
Oh,
Coal, yes.
Gas.
Gas.
Fossil fuels.
Yeah, they're all fossil fuels, right? So oil, natural gas, coal, nuclear energy. And yeah, so what are some of the disadvantages that y'all saw about renewable resources and renewable resources? The disadvantages.
looks like they destroyed the earth. I saw that. Different ways, like the renewable ones destroy it because it's like, I guess they got to clear out the area. It's also bad for the wildlife, and the non-renewable destroy the earth when they're spilled or let out or not kept properly.
Mm-hmm. Does anyone have anything that they want to add on to that?
Yeah, That sounds like what I was gonna say. It seems like when you put in something like a dam, you have to get rid of some things that are already there that were there before. So you
And you're
disrupt.
displacing them of their home.
Yes, you disrupt their home.
All right, y'all. Well, that's my presentation. Thank y'all for coming out. Appreciate it.